Today we're going to talk about potentiometers, and we're going to use our potentiometer as a voltage divider. Today we're going to cover pages 18 and 19 in our inventor's notebook. So let's start actually with page 19 this time, and look at this diagram. Our potentiometer has two connected resistors inside, as well as the wiper that sweeps between terminal 1 and terminal 2. If you rotate the wiper toward terminal 2, there will be more resistance between the wiper and terminal 1 and less resistance between terminal 2 and the wiper. If we sweep the wiper the other way toward terminal 1, there will be more resistance between the wiper and terminal 2 and less resistance between terminal 1 and the wiper. We essentially split the total resistance into two pieces. The place where you split the resistor will determine how much voltage you get out of the wiper pin. Let's go back to page 18 and fill in our traces. Let's flip on our battery and watch our potentiometer in action. As we rotate our wiper, more and more voltage is going out of that wiper pin and through our LED. Let's grab our blue paper and a couple of multimeters to see what's happening inside our potentiometer. Our potentiometer is a 10 kilo ohm potentiometer, and if we put our wiper directly in the middle, we can see that each side reads 5 kilo ohms. If I move my wiper toward terminal 2, the resistance on the terminal 2 side increases and brings me down to 92 ohms, which is practically zero when we're comparing it to 10 kilo ohms. On the terminal 1 side, we have 11.5 kilo ohms, which is around 10 kilo ohms. If we sweep back the other direction, the opposite happens. Here we've stopped between the wiper and terminal 1, and we can see that the resistance between the wiper and terminal 1 is around 2 kilo ohms. We can also see that the resistance between terminal 2 and the wiper is around 8 kilo ohms. Let's reconfigure our circuit to measure voltage instead of resistance so we can get an idea of how our potentiometer affects our voltage. With the way our circuit is wired, we can see that the multimeter on our left is showing us the supply voltage coming from our battery. The multimeter on our right is showing us the output voltage coming out of the wiper. When we sweep all the way to the left, our supply voltage and our output voltage are the same. When we sweep farther and farther to the right, we can see our output voltage dropping until we get all the way down to almost 0 volts. Using this method of voltage control, we can control the brightness of an LED, as we just did on page 18. On the next page, we're going to again control the brightness of an LED, but this time we're going to use only half of our potentiometer. You can see that we have only filled in the traces to connect half of our potentiometer. When we turn on our circuit and rotate the knob, the LED gets dimmer. If we replace our potentiometer with our dimmer switch from before, a similar thing happens. This is because now we are increasing and decreasing resistance rather than using our potentiometer as a voltage divider. You may notice that even with the potentiometer set to maximum resistance, the LED does not turn off. That's because our maximum resistance is 10 or 11 kilo ohms, and that amount of resistance still allows some current to flow. When we used both sides of our potentiometer on page 18 to build a voltage divider, we were able to make our LED dim and turn completely off. This makes our voltage divider circuit more useful for LED control. Today we learned about our potentiometer and how to use it as a voltage divider. Why don't you make some custom circuits that utilize a voltage divider? Thanks to Scribe for sponsoring this series of educational videos. All of the components in this video are for sale on the Scribe website, and if you use the code BERBAWYMAKERS, you can get 15% off. Also on the website is troubleshooting help if you're having difficulty with your pen or any of your components, and you can sign up for their live classes. I'm Ms. Berbawy. Tune in next time to learn about DP/DT switches.